I guess we can start then.
Ready when you are.
Yeah, I'll just check if they are able to hear us. All right. So, just want to make sure, can you all hear us? There is no reply yet, maybe. Okay, cool. So, good morning, everyone. So, today we have with us Dr. Hans, and we will be having a webinar on Is There Life on the Moon of Jupiter? So you already have attended some few webinars before with different scientists and astrobiologists. Today we will be talking about the moon of Jupiter, and we will be talking if there is life on it. So before I want Dr. Hans to introduce himself, and I guess Dr. Hans, the stage is yours.
Okay, thank you for introducing me and thank you all for having me. So I want to start with a question. What's the best place to find life in the solar system? Well, it's not Mars or any of the other planets. The best place that we can find life might be on the moon of one of the giant planets. Like this moon. It's called Europa, and it's one of the moons of the giant planet Jupiter. In the background, you can see Jupiter, its bands and its storm. In the front, you see that moon Europa. And this moon Europa has a surface of ice, frozen water. That's why it looks white. But what's really remarkable about this moon is that under the ice, there's an ocean of liquid water. And water is one of the things that we think are needed for life. So because there's water in this ocean, we think that there's also a chance that life might exist there. And because of this chance of life, different space agencies like NASA or the European Space Agency are working on space missions that will go there to find out if life could really exist in the moons of these oceans of the giant planets. In this
So,
presentation,
sorry to interrupt, but I just
yes,
got this chat that other students are also to join. Like there are more classes will be joining. So I just got a text here.
would you rather that I start again for the classes that are just joining?
Yeah, like they are like, can you please wait? And other
Yeah.
classes will join very quickly.
So I'll just start from the beginning again, as soon as you're sure that everybody's in.
Yeah,
Just give me a call when you're ready.
yeah,
No
I'll do that.
problem.
Thank you.
No problem.
Yes, Prahant. So I guess we should start. Some classes have some technical issues, so they will be joining from YouTube live stream.
Okay, then I will start again.
Yeah, thank
So I'll
you.
just start from the beginning. So uh, I want to start with a question. What is the best place that we can find life in our own solar system, except for Earth, of course? And the best place to find life might not be on a planet like Mars or any of the other planets. The best place might be on the moons of the giant planets of our solar system. One of those moons is called Europa. This is what it looks like. In the background, you see the giant planet Jupiter with its bands of clouds, giant storms, and in front of it, you see that moon, Europa. And this is what Europa looks like from closer by. It's a moon that has a white surface. It's made of water ice. But what's really remarkable about Europa is that under that ice, there is an ocean of liquid water. And water is one of the things that we think are essential for life. So because there's water inside this moon, we think that there's a chance that life might exist there. And because that chance for life, space agencies like NASA and the European Space Agency are developing space missions that are going to these moons to figure out if life could really exist there. In this presentation, I want to answer 3 questions. Why do we care about life and what does life need? Why could there be life in a moon of Jupiter? And if there is life, how could we find it? But before I go into these questions, I just want to introduce myself a little bit better. I'm Hans. I'm a space scientist. I'm originally from Belgium, a small country in Europe. And nowadays I work at the Dublin Institute of Advanced Studies in Ireland. It's a small island country in Europe. I've worked in a couple of other countries in Europe as a scientist, and I even spent some time in the United Arab Emirates. But now I'm based in Ireland. And so I'm a space scientist. I study the moons of Jupiter, and I'm part of the team of the JUICE mission. That's a new European mission that's on its way to Jupiter to study those moons and look for life. And the picture that you see on the left, that's me last April, with in the background the rocket that launched the JUICE mission to Jupiter. And then that brings me to my first question. What do we care about what life and what does life need? So the first reason why we care about finding life somewhere else in space is to answer a very important question in science. Are we alone? So far, we haven't found life anywhere else, not even a bacteria or a plant. So as far as we know at this point, we are alone in space because we haven't found any evidence for life anywhere else. But if we could find evidence for life, even just a bacteria, then that would tell us that we're not alone in space. And that would be a major scientific breakthrough. There is another important scientific question related to life that we could answer if we found life elsewhere. We would understand better where we come from. We know that all the life on Earth, all the animals, all the plants, they come from one common ancestor. This tree that you see in this diagram shows all the types of animals that exist on Earth, including humans, and it shows how they are related. All life came from one common ancestor, and the process through which life developed from that ancestor in the variety that we have today is called evolution. And what we could do if we found life anywhere else is compare that life with the life on Earth. And if we would figure out that that life is similar, that they shared a common ancestor, then that would tell us that the life on Earth wouldn't necessarily have started on Earth, but could have come from somewhere else in space. If instead we figured out that the life on other planets is very different from our own and doesn't have a common ancestor, then that would tell us that life has started independently of each other in different places in space. So if we could find another example of life somewhere else, then it would help us answer the question, where do we come from So those are some reasons why we would like to find life elsewhere in space, to answer the big questions of science. Now, what does life need? That's a very complicated question. There's no simple answer to it, but I'm going to try and make it simple for the purpose of this presentation. We could say that there are four things that all life needs to exist, based on the life that we know on Earth, at least. One thing is liquid water. All the life that we know on Earth needs liquid water to live. Another thing are chemical building blocks. Sulfur, phosphorus, oxygen, nitrogen, carbon, and hydrogen. Those elements seem to be present in every life form that we know on Earth. So they might be the most basic building blocks for life. Next to water and the chemical building blocks, we also need energy. Life needs a source of energy to exist. And on Earth, that's the sunlight. Plants and other small organisms use sunlight to produce energy, and animals, like humans, eat those plants to stay alive. So all life on Earth depends directly or indirectly from sunlight. And besides energy, you also need time. You need to have water, liquid water, chemical building blocks, and energy for a long enough time to give life a chance to start. So those are the four basic things that we think are needed for life. And so far, I've told you why we're interested in finding life in space, to answer the big questions. Are we alone, and where do we come from? I've told you there are four things needed for life. And then next, I want to figure out with you why there could be life, why we think there could be life on the moon of Jupiter. Or to say it in another way, why do we think that these four criteria, liquid water, building blocks, time, and energy, why do we think that those four criteria are met on the moon of Jupiter? Let's start with the first criteria, liquid water. We're in space, we're in the solar system. Can we find liquid water? Well, start with the first planet, Mercury. No liquid water. Venus, the second one, no liquid water. Third one, Earth. Of course, Earth has water, as we know. Mars, no liquid water. It might have a lot of liquid water in the past. It might have had liquid water. But nowadays, there's virtually no liquid water on Mars anymore that we know of. The giant planets that follow, they're gas planets. Liquid water cannot exist on their surfaces. So where can we find liquid water? Well, it turns out that we can find a lot of liquid water in the moons that orbit around these giant planets like Jupiter and Saturn. And one of these moons is Europa, that moon of Jupiter that has an underground ocean of liquid water. There's a lot of liquid water in that ocean. This figure shows Europa and Earth to scale. And next to each of them, there is a blue ball that symbolizes the volume of all the liquid water in each of these objects. So the blue ball next to Europa shows all the liquid water in Europa's oceans. And the blue ball next to Earth shows all the liquid water in the oceans, lakes, and rivers that we find on Earth. And surprisingly, there's more liquid water in this moon of Jupiter, even though it's much smaller than the Earth. Why is that? That's because we think that the ocean of Europa is 100-kilometer deep. That's 10 times as deep as the deepest point of the oceans on the Earth. And so with such a deep ocean, it's possible to have more liquid water than we have on the surface of the Earth. So that was the first criterion. How do we know that Europa has liquid water underground? We know that thanks to this spacecraft and these two scientists that you see here. That spacecraft is called Galileo, and it visited Europa more than 20 years ago. And by measuring the magnetic field next to the moon, these scientists were able to figure out that it must have an ocean. Krishan Khurana is one of the key scientists that helped discover these oceans of Europa, one of the major discoveries in planetary science. He's from India originally and currently works in the US. And he was working together with Professor Margaret Kivelson to make this big discovery. By now, she's 95, but she's still active as a scientist, and she's still studying these moons of Jupiter every day. So we think that for Europa, that these requirements are met, that there is liquid water, that these chemical building blocks are there. because they have been measured by spacecraft and telescopes. And we also think that the ocean existed long enough to give life a chance to exist. It's been there for billions of years, perhaps. The question is there a source of energy on Europa for life? And that's a bit trickier. And I'd like to explain why with this artist impression of what life could look like in the ocean of Europa. This is just an artist impression. I'm not saying that's what the ocean of Europa really looks like, but it helps us think about this ocean. Because there are a few things about this picture that are wrong and a few things that are correct, as far as we know. Think about that for a second. What could be wrong about this picture? Well, often people tell me, the sea monster. There are no sea monsters in Europa. Well, we don't know. That's the question. We want to know if life exists in that ocean of Europa, and we don't know yet. And if it exists, well, perhaps it's just simple bacteria instead of a sea monster. But even if we would discover bacteria, that would be a major discovery, because that would be the first life we detect anywhere else than on Earth. So that's not the incorrect part that I'm looking for. The incorrect part has to do with something else that you see in the figure. It's too light. The ocean of Europa has kilometers of ice on top. So inside the ocean, it will be completely dark. And as you might remember, light, at least on Earth, is the main source of energy. So how could life exist in this ocean of Europa if it's completely dark there? There might be a solution, and that has to do with these bubbly things that you see coming from the ocean floor. Those might really exist inside Europa's ocean. What are they? There are black smokers, like we find on the bottom of the ocean, on the Earth. The submarine that you see there is called Alvin, and it's a submarine that was used to discover the wreck of the Titanic. But it also discovered something very important, black smokers. These are sources of hot water on the ocean floor, and they look like what you see in the figure on the right. There's like dark, mineral-rich water venting from the ocean floor. And what's remarkable about these black smokers, you see them a little better here in a more recent picture, is that they're surrounded by life. Even though the water from these vents is almost boiling, a lot of life has evolved to live in this environment. Turns out that life doesn't need light. Those life forms there use the minerals and chemical substances from the black smokers to produce energy. Bacteria have evolved to use the substances from the black smokers to produce energy. And other forms of life, like these giant red worms that you see in the picture, they work together with these bacteria to get energy from themselves. So the life that exists here around these black smokers doesn't need sunlight, but gets its energy from the black smokers. And we think that such hot water vents could exist on the bottom of Europa as well, because we have good reasons to believe that Europa on the inside is warm, even though the outside is frozen. So in summary, we think that all the requirements for life are met on Europa, or we have good reasons to believe that they might be. There's liquid water, we think that the chemical building blocks are there, we think that there could be a source of energy, and we think that the ocean has existed together with these other two for a long enough time to give life a chance to exist. So there is a chance that life might exist there. Europa isn't the only moon with an ocean and not the only moon with a chance of life. Other examples of moons with oceans are Titan, the moon of Saturn, Ganymede, that's Jupiter's biggest moon, and Triton, that's a moon of Neptune. There are more than 200 moons in the solar system. Not all of them have oceans, but several of them, more than the ones I showed you here, might have oceans. But Europa is the one that we're most sure of, the one that we know the most about, and so far it seems like the most interesting one to look for life. So knowing that there's a chance of life in the ocean of Europa, that leads to the next question. How could we find life in that ocean of Europa if it's really there? And ideally, we would send a spacecraft to Europa that lands on its surface, that drills a hole through the ice and drops a submarine in the ocean that would then be able to explore that ocean for us. That's a very exciting prospect, and I'd love for that to happen, but it's extremely expensive because it's so technically complicated. And at this point, there's no space agency in the world, not the American Space Agency, not the European one, not the Indian one, not the Chinese one. None of them are willing to take on such a technically advanced and expensive project. It might happen in the future, but that's for sure decades away. So this is not something that's going to happen anytime soon. But we can still go there with space missions like the Europa Clipper from NASA and JUICE, the European mission. These spacecraft, they will fly around moons and go in orbit around them maybe, which will allow us to study the moons from a distance. And even from a distance, we can learn a lot about them, and we can learn a lot about the chances for life in their oceans. The one on the right, JUICE, is the one that I'm working on myself. It's been launched last April. It's on the way to Jupiter now, and it will study 3 moons of Jupiter. Ganymede, the biggest one, Europa, the one that you've heard about already, and Callisto, the 3rd one, that might have an ocean. And JUICE will not land on any of these moons. It will look at them from a distance by flying by or going in orbit around Ganymede. But even without landing, there's still a lot you can do. I'm giving one example here. What you see on this picture is a prototype of JUICE. It's an early version that was tested on Earth. And what I want you to focus on is the big red beam that you see in the spacecraft. That's one of its scientific instruments. It's a radar. And this radar can send pulses, radio waves, that can go through the ice, and it will bounce back to the spacecraft when they hit the ocean. And because we know how fast radio waves move, we can then measure how long it takes for the wave to be deflected back from the ocean. And by combining this information, we can then figure out how deep the ocean is, how thick the ice is, and how deep the ocean is hidden under the surface. So in that way, without even having to land, we can still learn a lot about the inside of that moon and the properties of the ocean. So in this way, a spacecraft like JUICE can learn about the moon from a distance. I told you already, JUICE was launched last April. This is the rocket with which it was launched, Ariane 5. It's now retired, but it used to be the European Space Agency's most powerful rocket. The launch site for the space agency is in South America, in French Guiana. And I was very lucky because I was able to attend this launch in person. That was a really important moment for me because I've been interested in space since I was a kid, and I've been working on space science for more than 10 years, and I've never seen a rocket from close by. So for me to go there and see the rocket launch in my own eyes, a satellite that I've worked on myself, that was a really it was really a remarkable day for me. And it was extra special because I was so lucky that I could watch the launch site from the observation post that was closest to the rocket. So I was just 5 kilometers away from the rocket when it launched. And that's really very close. And the first thing you notice when the rocket goes up is the smoke and the light. And a little bit later, the sound follows because it takes longer for the sound to get to you. And the sound is really loud. I imagine it's what happens if you would put your head in a jet engine. It's like a very loud, thundery like sound that comes towards you. You can almost feel it. It's so loud. And the second thing you notice is the light of the rocket. So I didn't expect this, but it was so bright that you have to turn away your eyes. It's like looking at the sun. So that's really super impressive when it goes up. And in 1 minute it's over, it's in the clouds, and it's gone on its way to Jupiter. And this is what the JUICE spacecraft looks like once it's in space, when all the parts are unfolded. It's a central box with giant solar panels to produce energy in space. And because JUICE is just flying around the moons, flying near them, we're not going to go directly into the ocean. And we won't be searching for traces of life directly. Instead, we'll be trying to figure out as much as we can about the ocean and figure out if they're suitable for life or not. And JUICE will be doing that with different scientific instruments. I've already showed you one, the radar, but there are many others. There are 10 in total. This is what they look like. Next, I'm going to give you 3 examples of space instruments. I'll tell you what they do, and I'll give you one example of a scientist that works with each of them to give you an idea of the diversity of scientists that's working with the space mission. This is the first instrument I'd like to talk about. It's the camera of JUICE. It will take very high resolution pictures of the moon's surfaces. The figure on the left is an example of the surface of Europa. And you can see it's full of cracks, all kinds of places where water might leak out of. And with this camera on JUICE, we'll be able to take much better pictures than we've ever taken before from Europa. We'll be able to learn a lot more. And one of the scientists that works with this camera is Cecilia. You can see her here. And she actually has a background in environmental and biomedical physics. So she came from maybe an unusual path into this field of planetary geology. It's almost like what a geology does. The work that she might be doing is analyzing pictures of these moon surfaces and interpreting them to learn more about the moons. This is another example of an instrument of what we could do. The scientist is called Murthy Gudipati. He's originally from India. He has a background in chemistry. And in his research, he has shown that Europa might glow in the dark. That's not something we can see with our naked eyes, but JUICE is a special instrument that can observe UV light coming from a moon like Europa or Ganymede and analyze that light. And with that instrument, we might be able to check if indeed Europa glows in the dark. And interestingly, Murthy has a background in chemistry, so he also came to this very interesting research from maybe an unusual path. Then I'll use myself as the last example. What you see on this figure is a topic that I'm really interested in my research. We think that water from Europa might be leaking into space from cracks in the ice, forming plumes of water. And if we could fly through one of these plumes, we might be able to take samples from the water in the ocean without even having to land. And maybe that would even give us some samples of traces of life, should they be there. And JUICE has an instrument that looks like this, that could take samples of the gases that are coming out of the ocean. It essentially allows us to sniff whatever is coming out of the ocean and tell us what the particles that are coming out of the ocean are made of. And myself, I work on this mission. I hope to be using the data from that instrument. I have a background in engineering. So also myself, I'm not a traditional astronomer. That brings me to the end of this presentation. I've told you that we are interested to find life elsewhere in space, to answer the big questions of life. Are we alone? Where do we come from? I've told you that the best place to find life in the solar system is not on any of the planets, but might be on the moons of the giant planets, which have underground oceans. And one of the most interesting of these moons is Europa. We have space missions on the way that one of them is already on the way. The American one will be launched next year. JUICE is on the way. It'll arrive there in 2031. So it's still some time. That's because Jupiter is so far and it takes a while to get there. In 2031, some of you might be old enough to be scientists yourself and work on this space mission. And what I've told you in this talk, or what I've tried to show, is there are different ways that you could get involved in a space mission. Different kind of scientists can contribute to JUICE. And it's not just astronomers that can make a contribution. It's also geologists, engineers, chemists, biomedical scientists. There are many paths that lead to space science. And with that, I want to finish this presentation, and I'm ready to take any questions that you might have about space science, about careers in space, or anything else that comes to your mind. Thank you.
That was an incredible presentation, Dr. Hans. So,
Thank you.
So students, now you can ask any questions you have. We will wait for your questions. You can unmute yourself. or you can type your questions and send us to the chat. Um,
I see a raised hand.
yeah, I'm asking to unmute. Yeah, you're unmuted and you can ask your question on the mic.
How is time requirements?
Sorry, I couldn't hear you very well. Could you say that again or write it in the chat?
How is time a requirement? How? I would like
There's quite a bit of noise, so I couldn't quite get. I heard something, how is something environment, but I'm not sure what was in the middle of your question.
Okay, so the student is asking how time is a requirement.
How time, yes. Life needs some time to develop. If you would put water, chemical building blocks, and energy together, you're not going to get life right away. It's not just magically, immediately going to start. It'll need some time to develop, we think. How much time it needs, we don't know exactly. But in the case of Europa, we think that these oceans have existed for billions of years. And that has been enough time to get life started on Earth. So it seems that Europa also had enough time because of that reason. I can see there are some questions in the chat.
Yes,
I'm going to go to those.
yes. The
Um,
next question is the water in Europa drinkable or not?
That's a good question. The water is just water. It's the same kind of water, H2O, as we have on Earth. But there might be other things in the water, like salts or other substances that we haven't thought of yet that might make it undrinkable. Like it could be too salty to drink, or it might even contain some poisonous elements. Who knows? And it's these kind of things that we'll know better with this future space missions like JUICE. They'll be able to analyze the chemical composition of the ice much better than we've done before. And from that, we can derive what's probably inside the water. And so in the future, we might know better if that water is really drinkable or really suitable for life or not.
Any more questions? We are waiting for your questions, and you can always write in the chat box or unmute yourself. Okay, so may I ask a question to you, Dr. Hans?
Sure.
So, yeah, so as someone who has worked with both space agencies and academic institutions, how do these different environments contribute to your approach in studying about these research, especially about Europa and finding life in the universe?
Um, as a space scientist, or as a scientist in general, you often end up working in different places in different countries. And because of that, you go through different places and you work with different people. And at every place, you learn something new. So I think for me, having worked in these different places in different countries, I've picked up something new in every place. And it makes you it gives you more skills and more knowledge as a scientist. Is that what you're asking about?
Yeah, like how do these different environments, like you worked in space agencies and academic institutes, so are there something different in both these environments which really
Yeah,
helped you moving ahead?
like academic institutions like universities or research institutions, they're more focused on actually doing research, using data from spacecraft and analyzing that data to learn new things about space. Space agencies like ESA, they have a slightly different role. It's their job to coordinate space missions, not necessarily to do the research, but making sure that a space mission is developed correctly, that it runs well, and that everybody's working well together. So from the space agency, you also learn about the science, but you also learn about how to organize a space mission. So you get a different perspective on how everything works by working in different places.
That answers my question. So there are more questions coming in.
Yeah.
So
Mhm.
yeah, the next question is black smokers are part of life. So how are they formed?
Well, I'm not an expert on black smokers, but I think the basic idea is that you're at the bottom of the ocean, and underneath the soil is an area where the temperature is hot, is high. And so some of the water from the ocean will leak through the soil, reach deeper where the temperature is higher, and then it's heated up there. And when it's heated up, the pressure increases and it will vent out back into the ocean. So it has to do with a source of heat under the surface of the earth that warms up the water.
Perfect answer. And moving to the next question, does Europa have atmosphere?
I think pretty much every object in space, like pretty much every moon or planet has an atmosphere, but usually they're very thin, those atmospheres. Europa also has an atmosphere, but it's really very thin. If you would be standing on the surface of Europa, you probably wouldn't even see that there is an atmosphere. Like on Earth, you can't miss it because the atmosphere is very thick. But on Europa, it's really very thin, but it's still there. It still exists. It's a very thin layer of gas that surrounds it.
We have more questions. So there's one question about Jupiter is a gaseous planet. Does its moon support land?
Yeah, you can't really land on Jupiter because it's a gas planet. It's basically a big ball of gas. But the moons are not made of gas. All the moons of Jupiter are made of solid material. Many of them have a lot of ice in them, actually, or at least on their surfaces. And you can land on an icy surface. That's not a problem. So you can definitely land on the moons of Jupiter.
Exciting. We have one more question. If the satellite has a ray that will bounce back on touching the ocean, how will we understand that there is an ocean?
That's a very good question. I think analyzing this data from a radar instrument isn't as simple as I made it sound. The reflected signal that comes back from the radar also contains other information, like if there are cracks in the ice or little holes in the ice, that will also change the reflected signal that comes back. So interpreting reflected radio signal and using that information to determine where the ocean is something that's really complicated and will take a lot of time to do well because there are so many things that influence the signal. So it is a complicated process and it involves a lot of research and a lot of researchers to do it well.
Okay, so we have one more question. What do we need to study to learn more about the moons of different planets?
Well, there's a lot that we can say about that question. I think one thing we could definitely use is more spacecraft. A lot of moons have never been visited by a spacecraft. Like the moons of Uranus and Neptune, we don't know much about them. There's only been one spacecraft that flew once by Uranus and Neptune and took some pictures from a distance from some of these moons, like Triton, that also might have an ocean. What we could really use is spacecraft that spends a lot of time going around Uranus or Neptune and also takes a close look at all of these moons. There's so much more we can learn about these moons. And for the moons of Jupiter or Saturn that we already know a few things about, what would be really great is to land there and drill and drop a submarine in the ocean. Or I told you about these plumes where the water is coming out of the moon. So what would be really cool is if you could send a spacecraft there that captures the water that comes out of the moon and brings it back to Earth so we can study it here in laboratories on Earth. So there's many things that we can do to learn more about the moons.
I can see there is one more question. Why cannot we use ultraviolet rays instead of radio wave?
Well, ultraviolet rays, they cannot penetrate through the ice. So we couldn't use ultraviolet light to look through the ice, but we will have a camera on JUICE that will use ultraviolet light. And there are different things that we could use the ultraviolet light for. For example, to discover if Europa glows in the dark, as predicted by the scientists that I mentioned in the talk. That glow is not something we can see in visible light, but it might glow in UV. We also know that Europa has aurora. It has polar lights like we have on Earth, except that they're happening all over the moon. And with UV, we can observe these polar lights or these aurora very well. So there are different things that we can use UV light for. Also, we can use the reflected UV light from the surface UV light from the sun that reflects back from the surface of Europa or any other moon. We can use that reflected light to learn more about its surface. So UV is there, but we can't use it to literally look through the ice like we can with a radar.
That's a nice answer. And I can't see any more questions now. So I guess it's all. So yeah, so thank you, Dr. Hans, for this enlightening webinar on this captivating topic. And we are honored to have had the opportunity to delve into this fascinating realm of astrobiology with such an esteemed expert we have. And your profound insights into Jupiter's moons, Europa, and Io have left us in awe and deep contemplation. Your extensive experience as a postdoctoral fellow at Khalifa University, a research fellow at ESA, and your academic journey through institutions like the Max Planck Institute for Solar System Research and the Swedish Institute for Space Physics truly reflect your dedication to advancing our understanding of the cosmos. And once again, I want to extend our sincere appreciation for generously sharing your knowledge and expertise with us today. Your passion for astrobiology and commitment to unraveling the mysteries of our universe have undoubtedly inspired all of us, especially the students of Sushila Birla Girls School who joined us today for this webinar. And to the students, your curiosity and engagement have been commendable. Events like these are invaluable for expanding our horizons and nurturing a scientific spirit. We hope this experience has ignited a spark of curiosity that will continue to burn brightly in your academic pursuits. Once again, thank you, Dr. Hans, for gracing us with your presence and for illuminating discussion. And we look forward to more such enriching sessions in the future. Thank you once again. And before we end the webinar, today's session, I also want to thank our partner organizations for their support in organizing and having this webinar. We have our representatives from Out of Inquiry, which is an organization dedicated to educating young explorers about system thinking through astrobiology, cognitive science, and world building. Additionally, we have also members from Lecturers Without Borders, which is a network of academic and STEM professionals partnering with schools around the world to give free outreach lectures to young students. So let's give them a warm gratitude as well. And now it's time for ending the session. And thank you, Dr. Hans, once again. And Dr. Hans
Yeah,
is saying if anyone has any more questions, feel free to send me an email.
right. Thank you for having me. It was nice giving a talk to you. And also thank you very much for the nice words.
Welcome. So we will end the session today, and thank you for joining us.